Hey, good morning, everybody. My name is Mark Freidenberg from Bentley University in Waltham, Massachusetts.
And I'm Gavin Bowman from Microsoft. I'm a technical evangelist.
And we're here today to talk about how we partnered together to create games and teach students how to create games as a way to develop digital literacy skills. Next one. So there's Bentley. It's about 12 miles from here, outside of Boston. It's a 4-year business school, and also there's a graduate program as well. The work that we're going to be describing today took place in a course called IT 101, which is a required course for all first-year students at Bentley. It's a course that teaches computer concepts and Excel and wireless networking and how to manage your laptop and basic technology concepts. And so as part of the course, we wanted to include a unit on game development, not because of why everybody else does game development, but for a different reason. It seems that many universities teach game development in introductory programming courses as a way to encourage student engagement with programming or through programming of games. But this course isn't a programming course that we're teaching. It's a technology concepts course, and so there really isn't any programming involved in the class, although students learn about programming. But they don't do any programming in this course. They do Excel, they do some HTML, but that's about as close to programming as they get. And my goal instead was to introduce this gaming exercise as a way to give students an opportunity to develop skills in digital literacy and in technology literacy, because some of the problems that they need to solve as they create computer games require them to be able to handle various technology literacy skills. And so the things that we wanted to see in the study of this was, can kids who have no programming experience create real software and create games? And how does the process of creating games and deploying them to the web and also to the Microsoft Store help develop digital literacy skills? Go on. So digital literacy is is basic technology literacy skills that are necessary for continued study, either in computer science or information technology. And digital literacy is really the ability to effectively use a technology and create digital artifacts. This slide is from a piece about digital curriculum from the UK, but it really gets at the essence of what we're shooting at is having students become facile with the technology they own and being able to use it responsibly. So here's what we did. We called Gavin. And we said, Gavin, what can we do to do something cool with digital literacy? And Gavin said, let's make games.
Because they're fun.
Because they're fun. And so we had an event. And the event was a 2-part gaming workshop that Gavin and his colleague Michael Cummings created or led for us. And the first part of the event was to use a program called Construct2, which Gavin will demonstrate soon, to create a simple video game. And then the second event, which took place a week later, was to learn some advanced techniques. So in the first event, Gavin showed them how to make a simple Flappy Birds kind of a game. And then a week later, they learned how to add score and music and create touch input and things like that. So more advanced skills. And then through the generosity of Microsoft, about 2 weeks after that, students had the assignment to create their own games, and we had a games party and chose some of the best games and ate lots of pizza, and it was quite the event.
Pizza's a great way to bribe students, guys. They're really cheap dates. Really.
So digital literacy. These are some of the skills that we looked at that we wanted to see the students be able to create and master in their process of creating games. Everything from learning that they can create a game using an application that we use called Construct2, and then save that game as HTML5 to publish on their website, as well as save it as in a native format that they could publish to the Microsoft Store. They had to learn how to use a development environment with Visual Studio. They had to interact with different operating systems because they were using Windows 7 on their laptops, but We needed to use Windows 8 in order to submit the games to the store. They needed to understand how to move files from one machine to another. They needed to figure out how to download stuff. They needed to know how to use multimedia responsibly, so they couldn't put their favorite songs as background music of the games if they didn't have the rights to do so. They needed to learn how to resize images, so they couldn't use pictures from their digital cameras that were really big when all they needed was something that was about that small as part of their game. So a lot of these digital literacy skills came up through the process of creating their games. Here are the steps involved. First thing they had to do was design a game using Construct 2. They had to create sound files and image files for the game. Then they had to export the game to the Windows Store and also for their websites. They published their games on their website, and then we showed them how to play their games on their mobile devices, on their phones or tablets, so that they could then play those as a web application in their browsers on their own devices. One of the challenging parts of this project was publishing the games to the Microsoft Store, and Gavin will tell us why soon. But that involves a whole bunch of steps that require students to read. They're not hard, but they have to read, because they have to read to create images for the backgrounds and for the store, for graphics and logos that have to be a certain size and a certain format. They have to test the games and create screenshots. They have to make sure that they put in appropriate descriptions and documentation and levels, and so it's detailed. And I think that was one of the biggest problems was reading and following the directions. The steps in and of themselves weren't hard, but following them
was an involved process.
Was an involved process. But the impetus for doing this was, as part of the assignment, anybody who got their game published to the Microsoft Store, we automatically gave full credit for the assignment. And the other impetus for telling them to do this is that by having a game published to the Microsoft Store, they could put on their resume that they have a piece of published software that was independently verified, which could be a resume booster. Let's show you a little bit about Construct 2 and the game that we showed the students how to create. So Gavin will give us a quick demo of how to use what Construct 2 is, how it works, and a little bit about the game that we created in class.
Cool. So like Mark mentioned before, Construct 2 is not programming heavy. Excuse me. I'm a big anime fan, guys. Let's duplicate this now. There we go. It's not programming heavy, but it does teach the concepts of video game event-based programming, right? And you have to walk through things like creating your own, your user experience and developing your own events in the game. So we're going to walk through that really quickly. I'm going to go ahead and open up Construct 2, which is it's a Windows desktop app. It's made by two awesome developers in France, whose names I can't recall, and I'm sorry. So I'm going to go ahead and kick up a new project, simple as clicking File, New. As you guys can notice, it's got a very similar sort of scheme to it, right? So when students get on Construct 2 for the first time, they already feel like they're using something along the lines of Office. So it's almost familiar to them, which is great. So the select template or example page shows you all the different types of demos and example content you can use. So if you want to work through something or see, well, how did these guys implement sort of a Super Mario Brothers platformer style game, or a Contra, maybe I run and shoot sort of game, you can scroll down here and find a bunch of different ones. But I'll be honest, I'm pretty hardcore, so I don't need a template. I'm going to go ahead and select a new empty project. We're going to click open. And the first thing I'm presented with is a blank screen with some stuff on the left side of the screen, some stuff on the right side of the screen. So from the left side of the screen, I can do everything from naming my game. I'll name it Gavin's Game, because that's so marketable. And I can give it a description that'll appear when I'm ready to publish my game. So when we did this with the students at Bentley University, we talked about the importance of building the game, but we also talked about the importance of coming up with a catchy name, right? Making attractive icons, something that users will want to use. And that's when it came to the publishing experience, making those icons resizable, and does this same thing look good at 640 by 300 pixels? So things like that. So the students not only learn how to make the game, but they also learn the marketing behind the game and how do I get the end user to want to use this, as well as deploying it to multiple markets, right? So maybe this is more popular in the United States versus this being popular, in New Zealand. The first thing I can do here is choose the size of my game by selecting my window size off to the left, and I'll put that at 400 by 500 because I want my game to be mobile, because who makes games for desktop anymore? It broke my heart to say that, actually. So I'm also going to change my layout here, and that's the visible area of my game. That's the non-visible area of my game, how large my level actually is. Once I click that, my screen gets significantly smaller. And I'm going to need some art, right? I'm going to need something to put in my game to make it a little interesting. So I'm going to go ahead, and I happen to have some files on my desktop. There we go. Flapping Bird assets, if my mouse wants to click today. My mouse can take the day off, but I can't. How sad is that? Cool. And yes, guys, this is Windows 10, and it's amazing. So I'll just drag in this background to give my to give my game a little flavor, right? And I'm just going to right-click that. I'm going to align it, make it look neat. Boom. And now I need the main character, my hero of my game, my bird in my game. I'll just drag him in. So from the start, we're teaching students, the importance of laying out their gaming, how important it is to make it look attractive to the user. And when I run it, Construct 2 is HTML5 based, meaning that when I run my game, it starts in a web browser. The good thing about that is from this, I can export my game to pretty much any platform with a browser, right, or a web view. So I can make my game for Android, I can make it for iOS, I can publish it as a standalone website. There's a lot of versatility in that.
We used Microsoft. You can probably guess why.
Yes, I forced them. No, kidding. They were more than happy to use it. Cool. So yeah, by default, this is how my game looks. There's not much going on here. So from here, we were able to talk to the students about the importance of prepackaged behaviors and giving certain elements in your video game world, some abilities that certain elements don't necessarily have. So by default, whenever I include a little asset in my game, they're marked as a sprite. So all I have to do to give my bird some intelligence here is by clicking him, heading over to the behavior section. I'm going to give him a little platform behavior, because that's essentially what Flappy Bird is. It's a platformer game. Let's see if I can find it. There we go, platform. I'll click add. And after I do that, my bird now understands gravity, though he doesn't understand the concept of a floor. So he kind of just goes off falling forever, right? And there's that. Now, so this is the layout sheet, right? This is a visual representation of my game, and I just gave a little functionality by adding a behavior. But I can also go ahead and do some coding using the event sheet in my game, right, to determine what happens when the layout starts. So I can do that by clicking my event sheet 1 tab. I'm going to go ahead and click add event. I'm going to select my bird. Now, what Construct 2 does with their event sheet, they use a really, really interesting sort of system. Whenever this happens, do that. That's literally the psychology behind Construct 2. So I'm going to select my bird. I'll click next. And I'm going to say, when my bird falls through the layout, I just want to reposition him at the top of the layout, something like that, right? So I'm going to say, bird is outside layout. Okay, I'll click done. And that's my condition, and now I have to have a response to that. So I'll click add action. I'm going to select my bird again. I'll click next. I never did this before. Now I'll use my bird and I'll give it an action. Let's see. What action can I give? I'll say spawn another bird, right? So spawn another object. Click next. And they want to know what object am I going to spawn. I said, I want to make a bird. And I'll put him right back at image 0.0. So let's see what that looks like. May not look like anything. So when my bird falls, I get another bird somewhere, but I can't see where that bird is because I didn't determine where that was. So one cool thing that we teach the kids is how to use user input to do things. So if I head back to my layout, I can go ahead and right click anywhere in it, click insert new object, and I can add touch or keyboard support as input. I'm sorry if I'm like bellowing out to you guys. Cool. So I'm going to go in and I'll use my mouse as input. I'll click insert. And maybe this time, now you obviously can't see input, but you can determine that the mouse is there by looking at the object type folder. But that's now I can add another event, and I can say, whenever I click the mouse, we're going to move the bird up, right? So I'll select the mouse. I'll click next. I'll use on any click. So now my condition is whenever I click anything, I'll add an action. I'll select my bird. I'm going to use the set vector y action by an amount of negative 500. Now it's negative because the x and y, the origin is at the upper left corner of the screen. Cool. So let's run that, see what that looks like. And now whenever I click the screen, my bird's jumping up now. Awesome. And now whenever he's outside of my layout, I make another bird, right? So you gotta see me move outside of the layout, I've got like 1,000 birds, and my game crashes. So now they understand, we talk about the importance of debugging in our game, right? And things of that nature. How cool is that? But so all I have to do is remove that. So that now when I run my game, my bird goes out of the layout. It's all good. Cool. So obviously this is a little involved process. It usually takes about an hour and some change to get a working prototype. But just to show what we work through with the students, I've got a quick demo of what the lesson looks like after. Looks like Flappy Bird. Click start button. Boom. Look at our happy bird galloping. So he's got a couple of events added in that just say, hey, whenever I go up, I want my bird to turn his nose up, well, his beak up, to make it look as if he's flying, right? And I want gravity to always be pulling him down. And so there's a series of events that handle that. I've also got some, events that happen all the time when students want to say, well, I always want the bird to be moving across the screen. And we go, well, how do we do that? And we talk about what a tick is in game programming and how it represents time over every instance where the screen has to be redrawn. So it's a lot of fun. Students learn a lot of technical stuff. They learn a lot of programming fundamentals. They also learn a lot of marketing. Okay, we've got the game made. How do I make logos and image assets for my game and promotional things? And we talked about the importance of having an awesome description for our game. I hope I'm not taking up too much time. Am I good? Okay. And so from there, we would talk about different examples of, different apps and games that have done really well and how to make sure that their game is done. So one of, and Mark knows this, one of the best things that I got to experience after delivering this session to Construct 2, this session to Bentley University students is I got an email maybe about 2 months after the whole season. And it was one of the students who really, really liked they loved the process. They loved making their game. And they go, well, we publish these accounts. Well, we publish under these Bentley accounts, but what if I wanted to take my game and make it into something else, like completely outside of school? He goes, can you guys take this down so that I can have it and work on it from here? And so he asked me for resources and things of that nature. And I also pointed him out to local game development communities because Construct 2 is respected in the local game dev community. So it's really cool. It's just something that made me happy. One of the things that we also wanted to show you guys is some cool examples of some awesome games that students made. So these are the top 10 from Bentley. So you guys can, I'll take a vote. Who wants to see what?
Can we have a volunteer to come up and play one of these?
Yeah.
This is the interactive part of the demo. Somebody has to get up. Okay, you.
We got gems falling from the sky, guys.
Sure, come on up.
We got Hungry Cat. That's okay.
That's okay.
Only I will judge.
What do you want to play? Try the gems game.
Gems game, okay.
Just click on. Oops.
You can use a mouse if you want.
So these are running off the students' websites. They publish the games to their website as well as to the store, and this is running off the students' website.
Yeah, you're going to have to tell me how to score.
I think you have to use the arrow keys to match. In this game, you're using the arrow keys to match the jewel with the colors on the bottom. Try the arrow keys.
I told you I'm the worst video game player ever.
Oh, I see how it works now. Okay. I think I get, so when you
Obviously
you
not
click
hitting
it,
the red arrow.
and then you use
So it was interesting because we showed them the Flappy Birds game, and this is actually one game that didn't look like Flappy
I get
Birds.
it. And where do I want-
We saw
oh,
Flappy
so
Birds
I'm
going
on
this
there.
way.
Okay,
We saw
got it.
Flappy Birds as a
Alright.
level jumping game where they turned the graphics and made it sideways. The assignment they had to do was to work with a partner.
It's really difficult. Goodness.
They had to work with a partner to create their own game over a period of about 2 weeks. And the games could be anything that they could imagine that they figured out that they could figure out how to do.
Yeah, so the world was their oyster on this. Another cool thing about Construct 2 is that there's a
Yay.
huge community
Thank
following
you.
behind it. So there's plenty of examples of different games that students want to do. We've had some really, really interesting takes on platformer video games. We've had some RPGs being made. Students taking it upon themselves to just go and just figure things out, which is awesome. It's also part of the program lingo, so it makes me happy.
We'll show one more real quick. Let's show the cat game. This was a fun one.
Cat.
Yeah, this was one of those falling games. Let it load up. Start. So we showed them the basic template of a start screen, an instruction screen, a play screen, and then how to add a game over screen when you're done. The water's bad, you gotta get the fish. Now, wouldn't you pay $0.00 to download this and put it on your own device? Thank you.
That was actually fun.
Thank you so much.
So Gavin did this exercise in about 8 presentations over the course of a semester in 4 different sections of IT 101. A standard section, a couple of honor sections, and an accelerated section. And so that was the same. The only thing that was different was the students. We had a couple of training sessions and the party at the end. These are the assignments the assignment that we gave had students create games with these basic features that we alluded to earlier: keyboard and input, and music, graphics, publishing the game, a game over screen, and a home screen, as well as some advanced features like keeping score, collision detection, randomizing things, placing objects on the screen, stuff like that. And then we graded them on a really important scale: acceptable, better, or best. Acceptable was you took the game that we created in class, like Flappy Birds, and you changed the picture of a bird to an airplane, and the picture of the pipes to a stalagmite or a stalactite or something like that, and the cave had and the plane had to avoid those. So if your game was the exact same game but with just different graphics or sound, that was acceptable. If you did something slightly different, that was better, and or if your game didn't play well, that was okay. And best was your game was like a really good game and was highly addictive. We also gave them some resources so they could use graphics and sound responsibly. We showed them opengameart.org, which is a site for downloading clip art and backgrounds and other figures for games, and Pixel Prospector, which has even more 2D graphics that are available for free. We showed them BFXR, which is an amazing site for making really annoying sound effects and explosion sounds and pickup sounds and dings and things like that. And then we
saying
showed them
annoying because I had the birds.
The video game name generator, just in case they had trouble coming up with bad names for their games themselves. They could go to this site and it would come up with really bad names for their games as well. And so we showed you some of the games that they played. And we'll show you a couple pictures about here we were at Bentley. Pizza, as you saw, is an important part of the project. Here the playing some of their games in our lab, and on big screen TVs to make it sort of, or on the smart board in the front of the room to make it sort of an immersive experience, because big screens are better than small screens when it comes to this. We surveyed the students afterward to see what they thought about the project, and I was curious to see what their attitudes toward programming were. Many thought they would like to learn to write computer programs, and after doing this they thought you can see they thought they could learn how to do it. And at the very least, what struck me at the last one, it would be helpful to know how to write software. Even though they didn't create programs in a traditional sense, this gave them the flavor of what it's like to be a software developer. As far as the assignment itself, creating the game was an interesting way to apply IT concepts. Most people agreed with that. A lot of people agreed that they were pleased with the quality of the game that they created, that it let them use the skills they generated or they developed in IT 101. It was a real, tangible, real-world project, and it gave them a taste of building apps. They also learned a whole bunch of, man, that's a really bad slide. They also learned a whole bunch of IT and ICT skills from collaboration. So we asked them, the top line is, which of these skills do you think are important as an internet or as an information technology professional? And then the bottom line for each skill is, which do you think is useful in game development? And so the ones that were the most important were things like collaboration and buying and selling online and using social networking and using spreadsheets. So it was just interesting to see, as we looked at this, which skills they thought were important for them as IT professionals, most of them, and also which ones were useful as in gaming, and the fact that this opportunity gave them, or this assignment gave them the opportunity to learn some of those skills. Obviously for gaming, multimedia, and software development and app development and HTML5 were the biggies, and for IT professionals, collaboration and buying and selling and understanding devices and how to store information in the cloud were among the important skills that they learned. Some things that students said: games can be easier to make than you think. If somebody else said, if you miswrite part of a code, something that you didn't expect occurs, you got to go with the flow unless something unexpected happens to work.
That's my favorite.
And then, so the other sentiment that was common among students was, it's rewarding to see a finished project after putting so many hours of development time. I learned to have a final vision, but also think that step by step makes that vision come into reality. So they really got a sense of critical thinking and algorithmic thinking and the ability to follow steps in order to be able to get their games both published to their devices and to their websites and to the Microsoft Store. Let's see. This is, for me, I was interested in this project as a way to promote authentic learning, which is characterized by some of these ideas you see in the boxes on the screen. The project clearly has real-world relevance. They're creating a game that they can use on their own device themselves. It's open-ended in that we gave the same assignment to everybody, but the games that they created were all different. So you can't really copy. You can collaborate, but you can't copy. The task was worked on over time. It started out with two very simple lessons that Gavin gave, showing them how to build the Flappy Birds game, and then they had a couple of weeks with some help sessions in between to build their own games. They got to explore the games from different perspectives. The assignment had them pair up with someone else if they chose to, because we felt that the development environment was different enough and new enough that someone might remember something that someone else might not remember, so they could work on the same game, but they each had to make their own version of it. So that was, I think, a really useful piece in the assignment because it allowed for that support with a partner in creating the games. As far as assessment goes, we had students who work in our lab, and then in later semesters as we did this project, we invited students who completed the game project in earlier semesters to evaluate all the games that the students created. There were about 4 sections each semester, so there were about 130 games. There's no way that we're going to grade 130 games. So we had a bunch of lab students and students from previous semesters sign up to volunteer to play games for the entire weekend. And we set it up so in sort of a blind review process so that each game was reviewed by at least 2 or 3 people. They had an online form that they could use to evaluate the game based on its playability and its originality and difficulty, things like that. And then at the end, we looked at the results and found the top 10. And it was from those top 10 that we had a games party and a games contest and invited the students who came to the games party to evaluate the games. And to evaluate them, we used an online Qualtrics form set so that it could only be submitted once from your IP address, and we had them submit it using their phones so they couldn't stock the ballot and vote for their friends' games more than once. And they basically had 100 points to give out over the games that they chose that they thought were the best. They created a finished polished product, and they had many different outcomes. So it was a really authentic and clear learning experience. What happened? Students got to build games. They got to be resourceful. They learned to publish software to the Microsoft Store and experience a different operating system and a development environment. And it was a pain, but it added value through the process of following the steps required to do it. And everybody who did this had a working game of some sort, which was really nice. There wasn't anybody who decided they couldn't do it or didn't want to do it. They had something, whether it was the same game that Gavin created with a different background, but at least they had something. And we saw more variations of Flappy Birds than you can imagine, but at least they did something. And so that's what we did. And we'll be happy to take some questions about how we did what we did, and or share some of the war stories behind and successes behind the project as well.
Did you compare this to Scratch?
In terms of a development environment?
Yeah.
I've only used Scratch a little bit. I think that the programming in here is, for the kinds of things we did, is simple.
I think I can answer that.
Please.
I think I've used Scratch to teach kids. I think Scratch is really, really great for a younger audience. So it's more rudimentary than Construct 2. Not saying that the barrier of entry is exceedingly high. It's not, but Scratch is really great for younger audiences and beginners to new users to computing as well as programming, right? So there's Scratch, and I think there's Construct 2. I actually taught Alice. So Alice is really good for, it's a 3D modeling software, yeah? Alice versus Construct 2, well, you're adding an entirely different axis, right? So I guess in that aspect, things would be more challenging. The primary difference between Alice and Construct 2 is that Construct 2 is all two-dimensional, which is great, but the event system is very, very similar. Alice is more or less scripted, where Construct 2 is more, it allows for more variables. Good question. I like Alice.
Are you going to do this again, and what are you going to change?
So we are going to do this again, right?
Yes.
Oh, good. One of the things that we're going to change, I think, is the submitting to the Microsoft Store. The process of doing that became difficult. Students got a lot out of it. At the beginning, when we did this a couple years ago, there were some credit card requirements in order to be able to publish games to the store that Microsoft has since lifted, which made the process somewhat easier. It took a lot of time for us to require students to do that because at the university, we're not using Windows 8, and it required Windows 8 computers that we had to set up in the lab to do that. So there was often a backlog of people waiting to get on the machines to publish their games. And so for us, while there's a great learning value in doing that, I think the overhead on that was kind of high. I like the idea of having them publish their games to their websites as HTML. We may change it to have them publish their games to a Microsoft Cloud product instead, so they can get a sense of using cloud storage in a different way.
Right. So the thing about publishing games, it became a relatively difficult thing to scale. It's at that point where you need, and this is for any platform you're trying to publish to, at that point you need to have the development environment for that platform, right? So it was at that point that I needed Visual Studio, and for most of these students, it was their first time seeing an IDE. So that got to be a little tough, creating their own logos and making sure that the right size requirements were met all the time was a little tough, because if a lot of students did it in Paint, they didn't check that box that says maintain aspect ratio, and they're like, I got my logos ready, and you come back, no you don't. And so they have to go back for another 20 minutes or so. So that was the only real challenge. So we learned that publishing games to the store it's hard to scale amongst 130 students. So yeah, we do plan on moving it to hosting these websites, these web games in Azure, and having them readily available for all the students as friends and things of that nature.
Which is great, because then they'll have access to learning about a real-world cloud service as well.
So in order to publish the game, you need to reserve that name in the store, and you need to do that from Visual Studio. So since they're web games, you just open it up in VS and throw in your logos and things of that nature.
The games have any advanced strategies, so you're going to deal with that, teaching strategy and how to develop that?
Yes. actually. A couple of the games in the top 10 did, which was really interesting because they went well beyond what we taught, in Flappy Bird. So, like the first game, Bounce, included some box 2D physics. They, learned how to use a physics engine that's really popular on the web. So we had to walk around that and, plan out different events of that nature. And I learned a lot as well, I won't lie, from working with that game. So yes is the answer to that question.
Mm-hmm. Is that correct? So, like, what percentage of the semester was this, and what other, in a nutshell, what other materials did you go over?
So the IT 101 is a first-year course that covers basic technology concepts, input-output devices, the web, making web pages, spreadsheets, wireless networks, security, whole catch all of stuff. In order to fit this in, when we spent two class sessions on this, right?
2 sessions.
I did not do the sections from the text on input-out devices or software. I had them read those outside of class, figuring they're going to learn more about input and output devices by using this project and creating games for their phone, and the same with software as well. So I required them to read the chapter on that and do the quiz on that. But in terms of topics, there was another topic I think that was on career planning or something that we talked about. But so it took 2 classes, and there were two concepts classes that I didn't provide a traditional material on, so we could do this instead.
So this was a week or 2?
It was 2 75-minute sessions a week apart.
Right.
And then in between those sessions, there was a help session, and Gavin spent more time we have activity periods in the lab when no classes are scheduled, so Gavin spent countless number of Wednesday afternoons helping people in there. And also the lab assistants who work in our lab help people with that. And then we had hackathon events on the weekend before the project was due, where we brought in lots of Mountain Dew and sweet things to keep people's interest and gave them the opportunity to work on their games together if they wanted to, and those were pretty well attended.
You'd be surprised how many students are motivated to come into a lab on a Sunday if you dangle an A in front of them.
And cookies.
And cookies.
That's us, in case you need that. Other questions? We have time for one more, or 1 or 2 more.
No takers? Was this fun, guys? Was this, yeah?
So
Awesome.
For me, the interesting part about this project was seeing what the students would create, seeing how many of them would create, Flappy something else, and how many of them would go a little further than the example that we did in class. And also the kinds of things that they needed to learn in order to be able to do the assignment that we take for granted as people who use technology all the time. Where most schools use game development as a way to teach programming, the impetus for us was to use it as a way to reinforce the technology skills that they learned in class and that they need to know in order to be able to use their devices and the internet effectively, and deal with creating multimedia, creating a mobile app, and doing all this stuff responsibly with the content that they include in their games.
And for me, it was fun.
Yeah. For you, it was a lot of fun. Thank you very
Definitely.
much.